What's up, everybody? Welcome back. Advent of Code. So today we're doing day 16. Yes, this is late. Things happen. Couldn't get to day 16 on the day. And we're going to be solving this as fast as possible. Goal is to get part 1 in 5 minutes or less and get part 2 in 10 minutes or less. Let's see if we can make that happen. All right, Advent of Code 2020, day 16. All right. So there's some issue with tickets. The fields on these tickets must have valid ranges. Okay. You collect the rules for ticket fields, the numbers on your ticket, and the numbers on your nearby tickets for the same train service. The rules for the ticket fields specify a list of fields that exist somewhere on the ticket and the valid ranges of values for each field. Okay, so we have some fields and we know what the range for each field is. For example, class is 1 through 3 or 5 through 7, which means that one of the fields in every ticket is named class can be any value in the range 1 through 3 or 5 through 7 inclusive, such that 3 and 5 are both valid in this field, but 4 is not. Okay, this is a little weird, but basically it's like you've got a ticket in a language you can't read, but you can recognize the numbers. And so you've somehow managed to piece together the rules for what values can be in each field, but so you have to like reverse infer based on the information you know about your ticket and the ticket of everybody that's sitting around you. So here is our input. Let's grab our sample input here. Okay, so first things first, we want to parse out all of these parts. So what I'm going to do is I'm going to start and I'm going to say let parts equals input.ns.components separated by 2 new lines. So this is going to get this section, this section, this section. Okay, easy enough. Next part. Let's get the field matches. So this will be this part right here. So let's grab, since this section we're working with, regex 101. Okay, so here's our test string. So the regular expression, first thing we want to do is we want to grab this part. So our first capture group is A through Z, or a space, and any number of those, and then a colon. Okay, so group 1 grabs that word. Okay, perfect. So that's the first part. And then there's a space, and then our second capture group is a digit. Any number of digits, that made it get the 13. And then there is a dash. Actually, let's make this whole thing the capture group right here. Because, so what we'll do is we'll grab this part, and then we'll grab the next part. So we'll grab that, and then we'll literally just repeat that right there. Okay, so we have group 1, group 2, group 3 for each of these. Okay, that looks like a regex that should get the job done. A copy. We're going to go try. I need to fix my regex parsing helper that I made. It's in a previous video if you want to go check it out to see how I made it. But basically, this will get the matches, but it's got so many exclamation marks. Okay, so now I've got this. This will get each of the fields as an array of strings. So now what we want to do is turn that array of strings into these ticket fields. So I'm going to create a struct that is called a ticket field to keep track. It's going to have a name, which is a string, and it's going to have a first range, which is a range of integers, and we're going to have second range is a range of integers. And we want this to be able to initialize from strings. So that's because that's what we have is an array of strings that's the regex matches. Now, the other thing that's going to be weird about this, so we want the range to be able to initialize from a string too. Like I can parse out the range, but I'm going to be doing this probably multiple times. So let's make an extension on range where element equals int. Is that how? Is it happy about that? Okay. And then we're going to create an initializer from a string. Okay, so what we're going to do here, we're going to say self.name equals strings sub 0. Not the whole thing, just this part. I'm going to say self.firstRange, actually equals, first range is so long to type. I'm going to do range 1, range 2. Okay, range 1 equals range from string, and then it's going to be strings sub 1. Strings, there we go. And then same thing for range 2. Okay, so now how are we going to parse the range? Well, so this parsing range is going to be a little harder. We basically need to get the 2 pieces. So let's simplify this. We are down to let's do this one because it has multiple digits for each one, the 13 and the 40 and the 45 and the 50. Okay, so then basically what we want for this part is we want to break these into capture groups. So that's a range, that's a range, that's a range, and that's a range. Okay, so now we get the 1, the 40, the 45, and the 50. Okay, perfect. That's our regex that's going to split up. That's going to split up this string and turn into some ranges. Matches, and this is our regex. Again, using our handy dandy raw string octothorpe there. Try. Okay, so then the next thing we're going to do is we're going to convert these into numbers. So let's do numbers equals matches dot map, or sorry, matches dot first dot map, because there's only going to be one. That's another thing I need to do, is make it so that for things that I know are only going to have a single match, then I'll have to unwrap it. Okay, so that'll get the numbers, and then it'll be self dot, oh shoot, already screwed this up, huh? Yeah, I think this is going to be wrong, because we actually, each range we want it to be the first part. So this is too much. So we actually only want this part right here. And so then this is going to be numbers dot first dot numbers dot last. Okay, so that'll get an individual range. This part is wrong. So basically, well, you can see this. We'll just do this in action here. Let fields equals field matches dot map, and we're going to do ticket field $0. We can actually see this. The string that comes in is not going to actually be right. Yeah, dang it. Come on, run. Oh, I messed up my main. Okay, so looking at our string, we have a 1 through 3 and a 5 through 7. Oh, I did do that right. Okay, that's good. So now range 1 and range 2. So So now we should have self should have a range 1, which is 1 through 3, and 5 through 7, which matches that. Okay, perfect. So we got the fields parsed out. That's awesome. The next thing we need to get is your ticket. And so your ticket is just a list of integers. If we go back to this input here, this is all we get for your ticket. So since we split on sections, we split it up by sections at the beginning. Let's do this section and write the regex for this, which should just be a capture group of okay, 7, 1, 14. Okay, I think that's all. That should be all we need for your ticket. So your ticket will be parts sub 1 dot regex matches hashtag that, and it is a try. Okay. So your ticket should be an array of strings, which is not exactly what we want. So we want to map that to int $0.first. Am I thinking about that right? Let's see if I'm thinking about that right for your ticket. It'll either make it or it'll crash. Did it get it right? Your ticket? Yeah, 7114. 7114. Cool. Okay, so that's your ticket. Now, the other thing that we're going to need is we're going to need all the other tickets. So other tickets is going to be the field, the parts sub 2. And we're going to be matching on this. So how do we want to split this up? I guess what we actually want, we can split this by new lines. Yeah, let's split it by new lines, and then we can just go by digits, and we can use the same regex there. So let's do that. So let's go parts.ns.components separated by a new line character. So that'll get us each of the lines, and then we'll do drop first, and then we're going to say map to what we need. We need the concept of a ticket. It's so annoying. Well, okay. So I guess what we can do here is we can say this will get us each line, and then what we want is we want to map, because this will get us each line. Yeah, an array of strings, and then we want to take each string, and we want to do try $0. Matches regex, and then we're going to use the same regex. So that'll split it into an array of array. How do we end up with 2 arrays deep? Dot first. I think that's what we want. Okay. Again, let's see if that actually is close. So what does other tickets end up looking like? Other tickets is 7. It's not first. See, this is what happens when you get these parsing things that get so deep. It's like you get them wrong. Okay, an array. An array of arrays. Oh, and then each of these have one thing in it. Okay. That's not what we want. I want to do like I want the capture groups to match up, so I don't end up with arrays of strings. Okay. Let's see. Let's split this up first of all. This will make this easier. So these are other ticket strings. And then let other tickets is going to be other ticket strings dot map, and then we're going to do, so this is a $0 dot map because it's we have nested arrays, right? So let's hold on. I'm gonna bring this back, and then what we're gonna do is $0 is an array of strings, and so what we're going to do is we're going to take each of those arrays and take the first item out of it, and I think that will turn our array of strings into just an array of integers. Yeah. Okay, that flattens it out. 7, 3, 47. That was stupidly complicated, but I think it's fine. Okay, so we've got the other tickets. So let's go back. So the problem is, what does part 1 problem actually say? It doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. Okay, so we need to find out which tickets are not valid for any field. And then what I'm going to guess we're going to do is we're going to go back and infer. So let's do this. Since we're going to be using this, we're going to make a type alias, which is just a ticket, and that is a type alias for an array of integers. And then we're going to do an extension on ticket, and this is where we're going to put like any helper functions or things like that that'll help us in processing these tickets. So the first thing we want to know, I'm going to do file private func part 1 is we want to know if based on the fields, which is an array of ticket field, and the tickets, which is an array of ticket. We want to know what the values. In this example, the values on the first nearby ticket are all valid for at least one field. This is not true of the other 3 nearby tickets. 4, 55, and 12 are not valid for any field. 4, 55, and 12 don't match any of these ranges, okay? Adding together all of the invalid values produces your ticket. Okay, so we want a list of the invalid values is what we're trying to generate. Okay, so that's not too bad. So what we're going to do, we need to collect the invalid values. And this is just going to be an array of integers. And then we're going to say for each ticket in tickets, and then we're going to say for the number in each ticket. And then we're going to say, what we need to know is, does the number match a field? It's basically what we're trying to figure out is, is this number on this ticket valid for any field on here? Okay, so pretty easy to do that. So let's do. We're gonna make this is gonna be file private. We're gonna make a function called. Actually, I don't need this anywhere else yet, but I might. And then we're gonna give it a number. We're gonna say, does this range contain? Or we don't need to do this for range. We need to do this for this. Oh my gosh, I can type private. we want to know if this ticket field can match the number. So we're going to say return self.range1.contains number or self.range2.contains number. Okay, so now we're going to, so that lets us know if the ticket fields and then to make our life well, not life easy, but make our code just a little cleaner, I'm going to make an extension on array where element equals ticket field, and we're going to say func contains, and it's going to be a number. And then what we're going to do is okay, and we're going to say for number for value in self if, or for not value, field, for each field in self if field dot contains number, return true. We found a field that can contain it, else return false. Okay, so what we're going to do is we're going to say does if fields does not contain the number, then invalid values dot append the number, and then we're going to do print invalid values dot reduce 0 plus. Okay, I think that solves part 1. Maybe, let's see. Part 1, fields and other tickets. 71. Did I do it right? 71. Okay, so getting the puzzle input here. Ooh. Let's do file private, let input equals 1, 2, 3, 2, 3. Okay. Let's see if this works for part 1. It should. 23009, and the answer we were looking for was 23009. Okay, that's time on part 1, I guess. Let's do part 2. Hopefully it's easier now that we've got part 1 really fleshed out. We've got all our data types that we wanted. Part 2. Okay. So part 2. Now that you've identified tickets that contain invalid values, discard those. Okay, so step 1, filter tickets. Then, using the valid ranges for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. If seat is the 3rd field, it is the 3rd field on every ticket, including your ticket. Okay, so now we need to go through and infer. So I'm going to give you a tip right here. If you haven't solved this yet, you're following along. Since I already peeked at this data and played with it before answering this, I already know that what ends up happening is you can basically assume that for each individual slot on a ticket, one of them is only going to have one possible field that it matches. One of them will have 2 fields that matches, and one of them will have all 3. And so all you have to do is find the one that only has one match and sort of narrow it down. So that's what we're going to do. So, so what we need for part 2 is we need the fields, which are the ticket field. This is a function. Ticket fields, we need the tickets, which is the tickets. And then we need your ticket, which is just a ticket. So then we're going to say part 2, which is fields, other tickets, your ticket. Okay, so that warning should go away now that we're actually using the ticket. Okay, so first thing it said to do was to remove any tickets that are just straight up invalid. So that's not too bad. So we're going to say let nearby tickets, tickets that are near you are tickets dot filter, and we're going to say fields dot contains tickets. And so this isn't like this is well, I was gonna write a function that goes that direction, but maybe that's not what we want. Well, okay, we can kind of do it one of two ways. So let's do it the other direction. Let's make it so that so we're gonna say $0 is valid for fields, and then what we're going to do is we're going to make an extension on ticket. So we have this like ticket type that we've made so that we can actually do stuff on it. We're going to say it is valid for fields, which is an array of field. Okay, so what we're ticket field. Okay, so what we're going to do is we're going to say for number in self, because ticket is just an array of integers. We're going to go through and we're going to say if fields dot contains the number. So if we find one where it just doesn't match at all, then we know that this whole ticket's invalid. Otherwise, we can return true. So yeah, so this, if the fields don't have any match for one of the numbers on this ticket, the whole ticket is invalid. Now we could have done this sort of either direction here, but this is a pretty easy way to do it because it matches the way that we've already parsed through this, and we already have this contains set up here. Okay, so we filtered out all of our invalid tickets. So let's talk about the next thing. So the next thing we need to do is we need to figure out for each ticket and for each row, because they said the rows are consistent. So like if this is class, then it's class for all of them. So for each index into a ticket, we need to find out which of these fields are potentially valid for it. So let's do that now. So we need possible fields, and we're going to take the name of the field and we're going to map it to an array of integers. I'm not going to map it to a ticket because we're not mapping it to a full ticket. We're just mapping it to individual indexes. So even though we have a type def for an array of integers, this isn't modeling the same thing. So that's why I'm not going to use it. Excuse me. So we're going to go through each field and we're going to see where it could possibly fit on each of the ticket slots. So which ones is actually valid for. And so what we want to know is what indexes is what we're actually looking at. So a set of integers. Okay, so those are the possible indexes that this field can fit into. And then what we're going to do is we're going to go through for I in 0 ... less than fields dot count. So for each field, we're going to say let is valid. We're going to know the field or the index is valid if the nearby tickets, so the ones that we've already filtered, all satisfy. I don't want that autocomplete. All satisfy this one thing, and that is that the field that we're looking at contains the ticket at the index. So what we're doing here is we're looking at all the fields. So class, I don't remember what else. Class, row, and seat. So we've got class, row, and seat so far. We're trying to figure out which indexes make sense. So for class, which indexes can class fall into? Well, the way that you can do that is you can say, okay, there is one column on each ticket for each field. So we're going to go through each column and we're going to say, okay, does this field that we're looking at, so does class contain each item on the ticket? Now, if there's any ticket that doesn't match that, so there's any ticket where the column doesn't fit that, then we know, because we only have valid tickets, that that this field cannot go in that index. Okay, so that's how we're going to get all of the valid indexes, and then we can say if is valid, then we're going to say valid indexes dot insert I. Okay, so now we have all the valid indexes for a field. So then let's this array right here, and then we're going to say possible fields sub field field dot name equals possible or valid indexes. There we go. So now the end result is we have a way of mapping. Oh, we did it as an array. There you go. Is it happy now? It is. Okay. So now, because the final thing that it wants to know is on each of these fields, once you know which one is which, it only cares about the ones that start with the word departure. So that's why we're doing it by name, because that's all we care about is the name. Once we're done, we don't need the whole field. Okay, so now that we have all of the possible fields that they can, all of the indexes that they can map into, so what we want next is we want to basically flip the script, and we want to say at each index which field goes there. So we're going to say var index to field is going to be an array as a dictionary of int to string. So that's the index and then the field name that's assigned to it. And the only reason I'm doing this as a dictionary is because then I don't have to deal with yucky array instantiation and to slot it in. Maybe it's more performant that way, but like this is fine. We don't have that many fields. Okay, so we've got all our possible fields, and we're going to go through and we're going to pull them out one at a time. So while we still have some possible fields to inspect, we're going to pull them out. And then what we're going to do is we're going to say for each key value in the dictionary and our possible fields, if the value.count equals 1. So basically we're going through every single possible field, and we're going to find the one that only has one possible match. If we found it, we're going to say let determined index. So whatever index we have determined has to be the final one, because there is only one value in its list of possible indexes. We're going to say index to field is the determined index, and that is equal to the key. Okay, so that will get us the first one, but what we need to do is we need to start whittling things down. So what we're going to do is we're going to make a copy of our possible fields, and then we're going to say for inner key and inner value, because we're inside a nested loop of possible fields. We're going to say let filtered equals inner value dot filter, where $0 does not equal the determined index. This is going to be a slow way to do it, but basically we're going to go through every single array right here. We're going through every single one of those, and we're going to filter out this determined index that we found, because we know that nobody else can be there because we've already found the thing that belongs there. Say copy sub inner key equals inner value, and then we're going to say copy sub key equals nil, and then we're going to say possible fields equals copy. So basically we make a copy of these possible fields that we're going through. We go through each one and we filter down not inner value filtered. Thank you, compiler. We go through and we pull, so in this case index 1, we pull 1 out of each of the arrays, and then we reassign them back into copy. Then, since we're done with this value that we just did, so if it's class, let's say that we use it for example, we're done with it. So we can actually remove it from all of our possible fields. We're done looking at it, we know it's not there anymore. And then finally, once we've done all the manipulations we want, we save that to possible fields. Okay, so then the last thing we need to do is we should have now a list of indexes and fields. So then what we're going to do is we're going to say, we're going to add up the answer. So for key value again, and index to field, and then we're going to say if value dot starts with destination, I think is what they said. Departure. If value starts with departure, then what we're going to do is say total times equals your ticket subkey. Okay, so that will go through, and this will say, so we've got all of the indexes, we've got the values, and so we're going to look at the keys and the values, and so we're going to go through and we're going to find each one. And once we know how they're arranged, so for example, in our real data, like departure location, let's say that departure location is the first one. Well, then we know that on our ticket, I should have scrolled up there, then we know on our ticket to look at the first number. So where did our code go? So for each key value, we've got a mapping of those. If it starts with departure, then go grab that same index out of our ticket and multiply it by the total, and we're going to print total. Let's run that. 145888731458887314153. Okay. Now that we've got a working solution to both parts, let's take it really slow, really quickly here, and just break down part 2 solution, because I think it's the actual hard one here. So first things first, filtering out the invalid tickets. This was made easy because we'd already made this is valid and contains, or we could make this invalid for out of this contains method that we'd already made. So the second thing here is figuring out the possible fields that it can fit. I love this all satisfy. So this basically looks at all of the tickets, which are everything in this list, and we say, I want the total number of tickets that all satisfy a given condition. And the given condition is that this field actually contains the number at that index. This is actually sort of like there's sort of a forwards backwards way you can think of this. You could go through each ticket and then go through each field and sort of like flip the for loop. I think it's a little easier to make sense of it when you do it with the fields on the outside and then look at each index once you're on the field, because it makes it so that you can just access fields.count, which otherwise you'd have to like peek inside and like get one of the individual arrays and see how long that is to know how many loops to do. And then it also makes it just easy to build the set of valid indexes for each field. Once you have the valid indexes, it's a little bit cheating, the fact that like they go 1, 2, 3, 4, like there's only like each one has an increasing number of valid indexes. If you actually had to go through and like process of elimination, like compare them against each other and get it so that each one only had one, this part of the solution would be much harder. So this is one of those where I would actually recommend, once you get this part working, and like this is for problem solving in general, once you have a big chunk of it working, run it on your data and take a look at it and see if patterns are emerging, especially in problems like this where the input is static. That's the only reason why this trick actually works. So even though this is like a little confusing to build up or to eliminate down to which index goes to which one, having to actually, like, let's say that 2 of them only had 2 and they like overlapped in some way, right? That would be much, much harder than just saying, oh, let's find the one that only has one possible thing, clean it up, and then keep doing that for the next one that only has one left now. But that's the only this is the kind of trick and simplification you can only find if you're running your data as you're progressing through the problem. Okay, then finally, nothing magic here. Just go through each of the key values that we've built. So the index and the name of the field, find the ones that start with departure, and index into your ticket and multiply that by the total. Okay, hopefully that helps with you guys understanding how to do advent of code day 16. Stick with us. This video is coming out a day late, but we're going to be doing this every day regardless. Day 17 is coming out shortly. Can't wait to have you guys join us on this one. Like, subscribe, you know the whole deal. Help the channel grow. Okay, we'll catch you in the next one. See ya.